in MATLAB chat.
Okay.
In MATLAB chat.
Oh, wait, that's not what I want to do. Control copy. Control copy. Control copy. I'm having trouble. All I can do is watch it in Discord. I'm having trouble. All I can do is watch it in Discord. Stop. I'm having trouble. All I can do is watch it in Discord. Stop. I'm having trouble. All I can do is watch it in Discord. Stop.
What about now? Can you hear me now? What about now? Can you hear me now? Can you hear me now? Can you hear me now? Yes, no, maybe. Yes, no, maybe. Yay! Okay, got it figured out. Yay. All right. Yay. Small adjustments must be made. Y'all did good. Y'all did good. All right, we'll give it just a second, make sure everybody's on. We're a little bit early, 1 minute. And then we can get started. And today what we're going to do is take what we did yesterday and just add the numbers to it. So yesterday we did the classical probability using the words, and today we're going to add the probability or the numbers with it. So the first step in solving all of these classical probability problems is going to be first to just get are all probability problems. Just get your mind wrapped around it. What is it saying? You know, what is the scenario? And then once you have your mind wrapped around it, then it makes finding the probability a lot easier. Much, much easier. I know, right? We need our coffee in the morning. First thing, we have to have our coffee. So I better silence this thing. We'll put it on Do Not Disturb so that I don't get that all class. Okay, so here we go. We're going to do some classical probability. And we'll go ahead and get started. Classical probability. So my son's into haikus. So he's got another haiku written for you today. A light in the dark, a warmth in the freezing cold. Miss Simpson is here. I'm here. So off it goes though. Okay, so yesterday we had this urn with some balls in it, and we talked about how this, represents our population of people or whatever things, and then we just sample from it. So this is a good way to show that sampling from a population. And then what's the probability that I get a certain item? Now yesterday I had what? Maybe I didn't have a purple. Did I have a purple yesterday? I had 2 reds. Try to get the same that I had yesterday, so y'all help me out. Did I have 2 reds yesterday and one blue and 2 purples? I did. Priscilla, my Fitbit died, and so my niece didn't need her Apple Watch anymore, so now I'm using it. I like it, but the Fitbit, the battery never died on. This thing, the battery dies on every night, so whatever. 2 purple. Okay, good. Is that what it looked like yesterday? Maybe. 2 blues, 1 blue, 2 reds, 2 purple, 2 red, and 1 black. Okay, good. Somebody was paying attention. Maybe. Perhaps. Black, maybe it was a black. 1 black. 2 purples, 2 reds, and a black. Okay, cool. Alright, so I want to use the same ones as yesterday because we already went through the process of doing the words on it. So, then yesterday, I think we were at first doing draw 2 from the urn, and then we wanted to know what's the probability that we draw 2 purples, or did we draw 2 reds? Can't remember. Yep, Switch called it purple and blue. Whoa, 2 different. I don't know my colors. I know I taught kindergarten for like ever, but colors are hard. Okay, so purple. Okay, so we're going to draw 2 purples, and the way we did it was we said we were going to draw a purple and a purple. So we did these words yesterday, and our job today is just to put the probability with it. So instead of how can I draw 2 purples, I'm going to ask today, the question is going to be, what is the probability? This black's no good. What is the probability I draw 2 purples? What is probability we draw 2 purples? So yesterday we just asked how can we draw 2 purples, and today we're going to ask what's the probability of it. So yeah, there are just 5 in our population, Adam. This is our whole population, and I want to know. I'm just going to pull out two from our population, so my sample size is just going to be 2, and then I want to know what's the probability that I get those 2 purples. So y'all are like got lots of different answers on there, so I don't know who to trust, and Kara said 2 reds, and then Bo said 2 purples, and then I don't know who to trust on there, but I already have purple, so we'll go with purple. Okay, so to get 2 purples, you told me yesterday it was purple and purple. So now I'm going to look at each piece of it. And I kind of need a little bit more for this experiment, because I need to know, when we draw them, are we going to take them out of the population and leave them out? Or once we look at the ball, are we going to put it back in before we draw out the second one? Because those 2 are going to give us 2 different probabilities. So let's start with 2 draws with replacement. In other words, I'm going to put it back in. I'm going to take out one of my balls, look at it, and then I'm going to put it back in to look at it. And good. What is the probability I have to draw a purple? You're exactly right. It doesn't matter if it's with replacement or without a replacement on the first draw. It doesn't matter. Because you're exactly right. There are 2 purples out of a total of 5 marbles. Okay, so I take it out, I look at it, I go, hey, it's purple. I put it back in, what's the probability then on the second one that I get a purple? Good job, y'all have already got it. So that's also 2/5, because now it's still two purples out of the 5. And the and then tells me just to multiply. Now, when I'm not adding, I like to simplify first. So if we can simplify in this step, we would simplify at this point. But there, the factors on tops are both 2s and both 5s on bottom. They don't go in, so we can't simplify it in any way. So we just multiply straight across. 2 times 2 is 4, and 5 times 5 is 25. So if I were to do this experiment 25 times, in other words, if I were to take out a ball, look at it, put it back in, take out another ball, look at it, I would expect 4, if I did that 25 times, I would expect 4 of those times to get a purple and a purple, to get 2 purples. Okay, now what about if we did this exact same thing, but we did it without replacement? So without replacement, purple and purple. Well, on the first one, what would my probability be? Still 2/5, right? We still got 2/5 because it's 2 out of the 5. But now it's without replacement. So I took this purple out and it's in my hand. That purple is now in my hand. So now what's the probability that I get that second purple? So now there's only, how many purples in there? 1 out of a total of 4. So notice it changed on that second one. It was dependent upon the first one. Once we drew one out, then the second one was dependent upon that first one. That and we're still multiplying though. Again, when I'm not having to add anything, if I can simplify ahead of time, I'm going to simplify ahead of time. So that this 2 goes into that 4. Because remember, we just multiply straight across, so that's going to be on top regardless. And so now I just have a 1 on top, and 5 times 2 makes 10. So there's a 1 out of 10 chance. In that case, if I did the experiment where I poured out 10 balls, if I did the experiment 10 times, only once would I expect to get 2 purples. Y'all are doing great. Great comments. Y'all are perfect. Okay, so now the next one we did yesterday, after we did 2 purples, we said, what about if we get no purples? So let's do no purples. Oh, maybe I should hold on to these for a second. The probability, I'm going to make myself a probability distribution table for both with and without replacement. So on that first one, we were drawing 2 purples, and the probability was 4 out of 25. The probability that we got 2 was 4 out of 25. Without, though, when we got 2 purples, the probability was 1/10. So we started this yesterday making a table, and we talked about the random variable was the number of purples that come out. So now all I'm going to do today is add that probability to it. So if I did the experiment 25 times, I would expect the frequency of them to be 4, where I got 2 purples. And here, if I did it without replacement, if I did the experiment 10 times, then I would expect to get 2 purples, 1. My frequency there would be 1. Okay, so now back to 0 purples. And we'll keep this without replacement. So 0 purples again. And again, you told me yesterday, we looked at the words and we said it would be easier just to say not purple and not purple. Remember, we went through all the different things and they were like, oh, that's too complicated. Let's just do not purple and not purple. Perfect. Y'all got these words. So now I want to know what's the probability that I don't get a purple on that first one. So, you know, out of there's 3 out of a total of 5. So my probability is 3/5. And tells me to multiply. Now I'm taking it out, and this one it's with replacement. So I got one of these 3, not a purple, looked at it, put it back in. Now I'm going to draw again. So what's the probability on the second time? It's still that same 3/5. Good job. So again, I'm not adding, I'm just multiplying here. So they can't simplify beforehand. 3 times 3 is 9, and 5 times 5 is 25. So the probability that I get 0 purples, so this is the number of purples I can get, is 9 out of 25. So this is how a probability distribution table works. So you're going to need that for your tasks. And we'll look at that again tomorrow, our probability distribution tables. Then what about for with replacement? On the first one, once we have the words down, it makes it nice and easy, because now all we're doing is just, I'll explain about the 3/5. So the not purple and not purple, once we have those words down, it just makes it so much easier to find the probability. So let me do a better job of explaining that. So there's not purple. Good, Bo, that does explain it. There's not purple. Well, there's 3 of them that are not purple. 1, 2, 3. Out of a total of 5 balls in there. And so that's why the probability is 3/5. Perfect. And then once I take one out, you're right, there's only 2 not purples left in there out of a total of 4. So there's 2 out of a total of 4 left in there. That and with the probability, you know, tells me that rule tells me I'm multiplying there. Again, when I multiply, I like to be able to simplify first. And so I'm going to simplify, and you're right, I'm just subtracting 1 from here because I took out one of the not purples and I took out one of the full population, so it just leaves me with 2/4. So now I like to simplify first if I can. This 2/4 is the same as 1/2. Now I can multiply straight across, and I've got 3/10. So again, out of 10 different experiments here, 3 of them I would expect to get 0 purples, or not get a purple. So 0 is 3/10. That's the probability that I get 0 purples. Now we did 0 purples, we did 2 purples, but we could also get 1 purple. So let's do that next. So let's get 1 purple. And again, we did this with words yesterday, so I'm going to make it go a little faster today, because you told me yesterday that we could get a purple and a not purple, because we could draw the purple one on the first one and then draw not a purple one on the second draw. Or we could do the not purple first and then do the purple. So being able to put it into words is going to be really helpful, because once you have it into words, now we're just putting those probabilities with it. So that's super, super important to be able to do. But we did that yesterday. So the probability of a purple on the first draw is 2 out of the total of 5. So 2 purples out of a total of 5. And the probability of not a purple, well, I put it back in. Remember, I take it out, but then with replacement, I'm putting it back in. So the probability of not a purple, well, it's 3 out of the 5. Remind me, what does the or tell me to do? What am I going to do because of that or? Good. I'm going to add there. And then So that's one way to get a purple first, is do a purple and then a not purple. Another way to do it is to do the not purple first. So one of these three out of a total of 5. And so once I've gotten it, I put it back in, so there's still 5 in there because it was with replacement. And then there's 2 purples inside, so it's 2 out of 5. Y'all are good. Okay, so now notice this time I'm adding in here. Remember when we add fractions, we have to have a common denominator. And since we have to have a common denominator, I don't want to simplify until the very end. So anytime I'm adding, I'm going to wait to simplify till the end. So I've got on top, I'm going to multiply these. 2 times 3 is 6. 5 times 5 is 25. Plus 3 times 2 is 6. 5 times 5 is 25. Notice that these guys are the same. Do you see how the numerator here is the same and the numerator there is the same and my denominators are the same? So I ended up with the same probability even though the order was different. So really I just had to find out the 625 and then I say how many different ways are there? Well, there was 2 different ways to do it. So I could add them together like this, or I could just multiply. I could go this 2 different ways and multiply 6 25ths by 2 to get that 12 25ths. Okay, so there's with replacement, if with 1, I've got 12 25ths. So here's the probability distribution. I can't get more than 2 because I'm only drawing 2 out of there. So I could get 0 purples, 1 purple, or 2 purples. And then this is the probability of each one of those. So with replacement, this is my probability distribution table. And if I've done it correctly, if these probabilities are right, then this plus this should make the whole set. You know, to get 0 marbles or 1 marble or 2 of the purple marbles, those are the only ways, you know, if I say, what's the probability that I get 0 purple, 1 purple, or 2 purples? Well, that should be 100%. So, you know, 100% of the time I should get either 0, 1, or 2. Good, it should add up to be 25 over 25. Or 1, does it? Let's see. That's 21 plus 4. Sure enough, it equals that 1. So if I've done all my probabilities correctly, this should add up to be one whole full thing. Okay, so now let's do it for without replacement. And how does that change things when I do without replacement? So still 1 purple. Still the same setup, purple and not purple, or not purple and purple. By the way, I'm going to get to grading today and comment. I'll leave you comments and such, and I'll grade those of you who have turned in. So from now on, you'll know if you've gotten it turned in or not. Hopefully, every morning I'll get up and just grade some. So you'll be able to say, oh, yes, it did upload to Dropbox or it didn't. And then also I can make comments. But some of you turned it in after yesterday's lecture. That's great. You've got until Saturday. If you make corrections and you upload something new, Dropbox is going to let me know, and so then I can go in and regrade it. So some of you yesterday were like, I didn't put in the ands and the ors. Let me fix that in that first day's homework. And you went back and fixed that. Good job. That's what you want to do, is make sure that you've got those ands and ors, because they're super important. And then today, maybe you've already turned in the classical probability homework. Maybe you already did that. If so, after today's lecture, if you're like, wait, I did it all wrong, go back and fix it and upload it, and I'll grade that new version. Okay, so now the probability without replacement, the probability that I get a purple on the first draw, well, it's still 2 out of 5. But now I've got this purple in my hand. So what's the probability? I should get this purple instead. I got this purple in my hand. So what's the probability that I don't get a purple on the second one? Well, there's only 4 marbles left, and 3 of them are not purple. So it's 3 out of the 4. The and tells me to multiply, the or I'm adding. Now, and Adam, it all depends on your internet and your setup, as well as mine too, but there's going to be lag. Everybody's lag is different. We experimented with this, and some people's lag is like 5 seconds, and some 30 seconds, and some people's is, so it kind of depends on the internet at each person's house. Because I was trying to make the lag go away, and we figured out that we can't. It's not possible. Okay, so now what about a not purple on the first draw? Well, out of the 5 marbles, 3 of them are not purple. But then, once I take one of them out, it leaves me with only 4, and I'm not replacing it. It leaves me with 4 marbles, and 2 of them are purple. That and lets me know to multiply. Okay, again, I could simplify, right? And if I can simplify in both places, then maybe I want to do it. But I want to make sure when I'm adding that I have a common denominator in the end. So maybe I just wait to simplify until the very end. So anytime I'm adding, a lot of times I'll wait until the end to simplify. So I'm just going to go ahead and multiply. 2 times 3 is 6, and 5 times 4 is 20. So I've got 6/20ths on both of those. Notice again that the probability was the same. That order didn't matter when it came to finding that probability. This one and that one, well, I just needed to know that there were 2 different ways to do that. This is going to be important next week when we talk about binomial and hypergeometric. So now I add across and I get 12/20ths, but I can simplify that. 4 goes into the top and into the bottom. So, I can divide by a fancy 1 to get 3/5. So the probability that I get 1 marble is 3 out of 5 times. Now, these guys should all add up to be 1, because I can either get 0, 1, or 2. So my probabilities should all add up to be 1. On this fraction, remember that I have to have a common denominator. So this is the same as 6/10. So let's see if it really does add up to be 1 full thing. 3 plus 6 makes 9, plus 1 makes 10. So we got 10/10, which is equal to 1. So that just lets me know that hopefully I did them all right there. And it lets me know that, they at least add up to 1, which is what it's supposed to add up to. I love your commenting. Y'all are doing great. Okay, so this is a probability distribution table. That's what this is. It just shows the possible outcomes. So there's my sample space is 0, 1, and 2. But they're not all equally likely. It is more likely that I'm going to get 1 purple than I get 2 purples. So, if I were doing a symmetric sample space, I would have to do that 0 9 times, the 1 12 times, and the 2 4 times to make it a symmetric sample space. How did I make the 6/10? Make it 6/10? 6/10. Oh, I just multiplied the top and the bottom by 2, Zoe. 3 times 2 gives me 6, and 5 times 2 gives me 10. So I just multiplied the top and the bottom by that. And I wanted to do that because when I add it up, I want a common denominator. So I just, multiplied the top and the bottom by 2 over 2 here. So I got the 6/10. Okay, so now let's do blue and then red. So yesterday, or maybe I did purple and then red. So we have purple and then red. And let's first do it with replacement. And we did the words yesterday. We said, well, the only way I can get a purple and then a red is I have to get the purple first and then a red. So that made it nice and simple. And if I'm doing it with replacement, well, my purple we've looked at over and over again now is 2 out of the 5. And tells me I'm going to multiply. The probability I get a red, well, in this one I'm putting it back in. I'm replacing it. So once I put it back in, it's 2 out of the 5 again for that red, because there's 2 reds. So now I'm simply multiplying, so I just do 2 times 2 is 4, and 5 times 5 is 25. By the way, I'm done with this. This was just for purples. And this particular example is one of the ways to do that. But it's not all the ways to do that, because I could also get a purple and a black. We said purple and not purple because it just made it easier. So I'm going to get rid of this probability distribution so we don't get confused with what that is. All right, now without replacement for the same thing, purple and then red is still purple and red. And the only way it changes is on the first one, the purple is still 2 out of 5 because there's 2 out of 5 in there. And it's still multiplication. The only way it changes is now I have one of those purples in my hand. I'm not putting it back in. So it leaves me with 1 out of 4. I'm not going to do any adding, so then I'm going to reduce. So 2 goes into 4 2 times, so I will have it end up with 1/10. There we go. So there's the difference between with and without replacement. Now, I'm going to do this same thing, except I'm going to remove one word. Instead of saying and then red, I'm just going to say a purple and a red. Not purple and then red, I'm just going to say a purple and red. So notice all I'm doing is taking off that one word. That's it. Oh, you're right. There are 2. Good catch there, Tish, because there are 2 reds in there. You're exactly right. Good catch. Good catch. So that I still end up with, instead it's 2/10 or 1/5, because while our purples went down, our reds didn't, did they? So it should have stayed 2 instead of the. You're right, exactly, because it's half a chance that I get that red one. Good catch. Good catch. I was just waiting on y'all. I was checking to make sure you're with me. That's what that was, yeah. As always, making sure you're here. Good catch, Tish. Watch for a bonus point. There's probably going to be a... Anyway, okay, so there's your with and without replacement. Okay, now I'm stealing away this word. And then. And we kind of looked at that yesterday. So what that means is I've got a purple and a red, but I could also do or in the other order. So by taking away that then, well, then I could do it either way. I could do it this way, or I could do it that way. And the same thing's going to be true here. The minute I take away that and then, the order, I could do it either way. I could get my purple first and then my red, or I could get my red first and then my purple. But notice, this probability is the same. I just have to do it twice. Because now I've got that or in there, and I find the probability of the red first, and then I put it back in, so the probability of the purple is still the same. So my probability for each one of these stays the same every time, regardless. Excuse me, this probability for purple because I'm putting it back in, I'm replacing it back in every time, that probability stays the same each time. Whereas over here, the probability changed dependent upon this first one. So that or, so the probability of my red this time is 2 out of 5. Notice that these guys are different. They're not the same probability. And the purple is now, well, I only have 4 marbles left, but there are still 2 purples in there. So while these probabilities are different, if you look at the full thing, there's still a 5 on bottom and a 4 on bottom, a 2 on top and a 2 on top. So while each individual probability changed, the probability of getting a red and a purple is the same as getting a purple and a red. So I'm going to go ahead and do that simplification where I get 1/2, because then I'll end up with 10 on both of them, so I can add it together. A lot of times I'm careful to wait to simplify, because when I'm adding, I want to make sure I have common denominators. So, and I could even simplify again to do this 2 and that 2. But since their probability is going to be the same, I should end up with the same denominator. So maybe we simplify again, make that a 1, make this a 1. So we should just end up with 1/5 plus 1/5, which equals 2/5. So the probability there is going to equal 2/5. All right. Now, yesterday we did 2 of the same colors. So let's look at that a minute. So 2 of the same colors. And so if I'm putting it back in, yesterday we looked at it and said I could get a purple and a purple, or I could get the red and the red, or I could get the black and the black. Now we said that we could do that yesterday, black and black. Because I take it out, I look at it, but then I put it back in. So I can get black and black with replacement. But when I do without replacement, and I do 2 of the same colors, so I can still get a purple and a purple, because I can take out both of these purples. I can still get or a red and a red, because I take out both of these reds. But think about the black for a minute. If I take out the black, can I on the second draw get another black? So yeah, that's all I can get, exactly, is purple and purple, or red and red. That's it. I can't get the black and the black. So without replacement, my probability is going to be a little different. So here I have a purple and a purple. The probability of the purple on the first one is 2/5. And the probability on the second one is 2/5. Or the probability of the red is 2/5. And because I'm putting it back in, the probability is still 2/5. The probability of the black is 1/5, and the probability of the back is 1/5, because there's 1 out of the 5. I take it out, put it back in, it's still 1 out of the 5. Now, nothing simplifies here, but you can see how if one of them did simplify, you might not want to simplify first because of these additions. I need the common denominator to be the same. And so right now, it's going to have a common denominator. But if I were to simplify one of them somewhere, then they wouldn't have a common denominator. So anytime I'm adding, I like to wait till the end to simplify. Okay, I'm going to go ahead and multiply. 2 times 2 is 4, 5 times 5 is 25. Plus 2 times 2 is 4, 5 times 5 is 25. plus 1 times 1 is 1, 5 times 5 is 25. Now I add them together. My numerators, remember, you just keep your denominator, add your numerators. 4 plus 4 is 8, plus 1 is 9. So there's 9 out of 25 chance. If I did this experiment 25 times, I would expect 9 of those times for me to get the same color. Over here, I've got 2/5 for my first one, 2 out of the 5. But now I've got this purple in my hand, so I just have 1 out of the 4 for the probability for the second one. Or the probability of getting a red on the first one is still 2/5. But once I take out one of them, I'm just left with 1 out of 4. So, and 1 out of 4. Since I'm adding, I'm going to wait to multiply, and it is the same as 9. I'm going to wait to multiply until, simplify until the very end since I'm adding. So I've got 2 out of 20. 2 times 1 is 2, 5 times 4 is 20, plus 2 out of 20. Add those together and I get 4 out of 20, or that's 4 goes into 20 1/5. That simplifies down to 1/5. All right, so there it is with 2 same colors, and you can see how this is different depending on if I've got with replacement or without replacement. I have to be able to think through the scenario and go, wait a minute, I can't get 2 of the blacks. I can only get 2 purples and 2 reds. All right, then we did yesterday 2 different colors. We did 2 different colors. And I think we talked about yesterday that if you get 2 different colors, then that's the complement of getting 2 of the same. You know, if I don't get 2 of the same colors, then I'm getting 2 different colors. So those make up the full set. So I can just take this and say, hey, look, this is the complement of 2 different colors. So for to do 2 different colors, I can use this. Remember, to find the complement, you do 1 minus. So 1 minus 9 over 25. Make that into a common denominator, so 25 over 25 minus 9 over 25 equals 16 over 25. So if we think about the probability distribution for this, my x, my random variable here is, or my sample space is 2 the same color or 2 different colors. You know, that's the sample space. And those 2 should make up the whole thing. I either get same or I get different. And my probability for 2 of the same is 9 out of 25. And the probability for 2 different is 16 out of 25. These guys are complements of one another. Over here, 2 different, I can do the same thing. They're complements, so I can just subtract 1 minus the probability I got there. I'm going to turn that 1 into 5s, so 5 out of 5. Not the complement meaning, yes, the complement meaning the opposite. You're exactly right, Amani. Not like, I'm so beautiful today. Yeah, when I tell y'all are great students, you work so hard, you're fabulous. Those are compliments, but this is a compliment with an E rather than a compliment with an I. So I've got 5 over 5 minus 1 over 5. So this is 4/5. These two make up the whole set. So looking for the complement sometimes can help you, because if I were going to go through and do all the ones that were different, we kind of talked about it yesterday that I'd have to do purple and black, or black and purple, red and black, or black and red, red and purple, or purple and red. Man, there's going to be a lot of different combinations, and I don't want to have to figure out all those combinations. Sometimes we just have to. But if you can use the complement, that'll really be helpful. So look for those complements within those problems. Okay, so there's our balls in an urn, and then we moved on to the fish yesterday. So let's do the same fish problems we did yesterday, except now let's find the probability for each one. So yeah, let me remind y'all what the complement is. So let me go back and do that again. Let me define that better. Remember that the complement of an event, so if I have some event E and I know the probability of that event E, that probability plus its complement, so the complement of an E, we denote it like this, or sometimes we denote it with a bar over the E, or some people will put a P with a C up there, the complement. There's lots of different ways to do that complement notation. But those two together, when I add the probability of the event plus the probability of the complement, I get 1. Or you can think of it this way, the complement, not getting this is equal to 1 minus the probability of that. So when we talk about complement, it's just the whole thing minus part of it. So that's what I mean by when I'm talking about complement. That's that definition. Okay, so back to the fish. Let me erase this and then we'll do fish. So with the fish, yesterday we had some red fish, blue fish, 1 fish, 2 fish, red fish, blue fish. So let me draw those fish up here again. We had 4 red, we had 3 blue, we had 1 that we couldn't see, yellow or orange, and then we had 2 rainbow. My rainbow may not look the same as they did yesterday. I think that's all we had yesterday. And we figured out, first it was catch 3 without replacement, or we're going to catch 3 without replacement. So 4, 3, 1, and rainbow. I think that was it. Okay, so first we're gonna, our experiment is to catch 3 fish. And we're gonna do it without replacement. So we're not gonna put them back in. We're gonna catch them and eat them. Not putting them back in. So, I want to know what's the probability I catch 3 red. Now, yesterday we put it into words, so that's a big deal. Is first we've got to be able to say red and red and red. But you have that done now. So if you do day 1 of the classical probability day 1, you have it written down in words. Now you just need to add the probabilities to it. So once we have the scenario down, then we can go back and say, okay, what is the probability that I get a red one on the first draw? So that's my next task, is to go, all right, how do I get the probability, what is the probability of a red one on the first one? So remember, it's the total number on bottom. So how many fish do I have total? Good. And then how many red ones do I have? Good. And I'm multiplying. Now I took a fish out. Here it is in my hand. There is one of the red ones right here. Here he is. So how many red ones are left? You've got the right idea, Cheesecake. It goes, from 4 down to 3 red ones. And I had 10 fish, but now I'm down to 9. And then I do it again, and it's going to go down again. So 10, 9, and then only 8 of them with 2 red ones left. I think there are four red ones. Okay, good. Y'all are with me. Okay, good. Okay, I'm not doing any adding, so I can go ahead and simplify. I'm going to go ahead and simplify this problem. So this is 2/5. And this one is 1/4. Oh look, I can do more simplifying. See this 2 and that 4? I'm going to go ahead and simplify this 2 and that 4 to make that a 2. Now I can multiply across and I get 3 on top. Oh, wait a minute. This can simplify too, can it? This becomes 1/3. So you're right. On top I just end up with 1. And 5 times 6 is 30. I knew it must simplify because Adam had 1/30 up there. So it's 1/30. Perfect. So out of 30 times of catching 3 fish without replacement, one of those I should get 3 reds. I expect to get 3 reds. Let's go ahead and do our probability distribution. Let's make us a table. So the probability, first of all, let's look at the outcomes. If I'm catching 3 fish, how many different red fish can I get? Well, I could get 3 red. All 3 of my fish could be red. Or I could get 2. Or I could get 1. Or I could get 0. That's good, Eve. I'm glad to know that's who it is. So I don't have to call you Cheesecake. Or maybe I can call you Cheesecake, either way, whichever. All right, so the probability there is 1 out of 30. So again, if I did this experiment 30 times, my frequency of getting 3 red, I would expect it just to be 1. All right, now let's do 2 red. Oh no, I'm still catching 3. Still catching 3, but I'm going to do 2 red. Remind me how we did that yesterday. Give me the words for it. So I can write the words up here. And then it makes it easy to find the probability. So remind me how we did it yesterday with the words. Y'all flip back on those notes. You've got them written down, right? You're taking notes just like you would in class. That's how this is working. I'm hoping anyway. So we had maybe we did a red on the first one. And not red, red, and red. Okay, cool. Not red on the first one. And red, and red. Is that the only way to do it? Or we can move that not red around, right? We could do it on the second one. So we could get red and not red and red. Or that not red's got to go one more place. So red and not red. Hopefully that's what we did yesterday. Something like that anyway. Okay, once you have those words down, then we just put the probabilities with it. So what's the probability I get the not red on my first try? Well, there are 6 not reds out of a total of 10. And I have one of those not reds out of there. I caught it and ate it. It's gone. So now there's a red left, 4 reds left, but only 9 fish in there. And now I've eaten a red and a blue, a not red, so I only have 3 reds left and 8 total fish. Or red on the first one is 4 out of 10. Not red, well, I'm down to 9, and then I'm going to be down to 8, so I can go ahead and put those on there. Not red, there's still 6 of them, but one of the reds is gone because I took it out here, so I only have 3 left. Notice that this is the same as that. They look the same, the tops do, even though they're out of order, it's still the same probability in the end. So now that we know that there are 3 ways, really all we have to do is find out this probability and multiply it times 3. But we'll keep going. Our red is 4 out of 10. We're going to go down because we're keeping 1 out each time, so we're without replacement, it's going to go down each time. And then the red on the second one only have 3 fish left, and then I still have 6 of those non-reds. So again, notice that it's all the same. I've just got 3 of those. So since they're all exactly the same, and I've got 3 of them, I could just multiply 3 times whatever the probability of one of them is. So let's go ahead and just simplify. That goes in there 2 times. This goes in there 3 times. Oh look, 3 times 2 gives me 6. So I have a 6 down here on bottom and a 6 up there on top. So I'm gonna cancel out this 6 on top with that 6 on bottom. That becomes 1. So I really just have 1/10 for all of those. And if this one's 1/10, and that one's 1/10, and this one's 1/10, it's just 3 of those, so it's 3 out of 10 chances. Or 1/10 plus 1/10 plus 1/10. Because this is going to be 1/10. My board is not big enough. That's going to be 1/10, and that's going to be 1/10. So the probability here is, I'll write it down here too, 3 times the 1/10, which gives me 3/10. So to get exactly 2 redfish, I've got 3/10. Okay, now what about 1 redfish? Maybe I don't have to erase it all. Because look back and see how we did 1 red. But I think I can just turn this one into a red and turn these guys into not reds. Because I could get a red and a not red and a not red. Or I could just move that red around. So now let's make this not red a red and make the other 2 not reds. And here, my red, not red, not red. So I've got one red here, one red there, and one red there, and I've got it in each place, at the front, in the middle, and at the end. Now I'm just finding the probability of each one. So the words were the hard part. Once you have the words down, then we just have to figure out the probability. Well, sometimes figuring out the probability is hard enough on its own. So to find the probability of a red, well, there's 4 out of a total of 10 of them. And not red, well, once I take it out, I'm down to 9 and 8 again. And there are 6 to begin with, but then once I take one out, I only have 5 left. Or start with 10, then I only have 9 fish, and then 8 fish again. Not red, I start with 6, then 5. And the reds I have 4. So again, it's going to be that same thing over and over again. It's just a matter of figuring out one of them. And once I figure out one of them, then the rest of them kind of fall in line. 5, 4, and, this is 6 and 5. Sorry. 6 and 5, and then there are 4 reds. So let's look at the probability of just one of those. So 4/10 times 6/9 times 5/8. That's just one of these, but they're all the same. I could do that 3 times because there are 3 different ways. They're all the same probability. So now 4/10 is the same as 2/5. 6/9 is the same as 2/3. 5/8, and I'm still multiplying it times 3. Notice there's a 5 here and a 5 there. Notice this 2 goes into that 8 4 times. And then this 3 out front really is over 1. 3 of them. So this 3 and that 3 we can simplify as well. Oh, and that 2 and that 4 simplify. This 2 on top and that 4 on bottom. So it looks to me like it's a half a chance. 1 on top out of 2. Is that what y'all got? 1 out of 2? Did I do any math wrong there? I could have. We can always check ourselves with the probability distribution here at the end. We can check ourselves to see. Good job, guys. All right, so now let's do 0. So the 0 fish, 0 red fish, in order for me to get 0 red fish, there's really just one way to do it. I have to get a not red, a not red, and a not red. 0 red fish. I have to get a not red, and a not red in order for me to get no reds. So to get a not red on the first one, well, it's 6 out of the 10. I'm down 1, so now there's going to be 9 and then 8, just like before. But now, instead of having 6 not reds, I'm going to have 5 not reds. And instead of having 5, now I've taken 2, so now I just have 4 of them. And that's the only way I can do it, is not red, and not red. Yes, Bo, I'm just putting that because it's a whole number, so I just put it over 1. You're exactly right. Okay, so now I'm just going to simplify this. We got 3/5. I'm going to simplify that. No, I can't. 5/9. And this is 1/2. But I am going to keep looking for things to simplify. I bet y'all see them already. Like this 5 and that 5. And this 3 goes goes into that 9 3 times. So on top I have 1, and on bottom I have 6. So 1 out of 6, 1 out of 6 chance All right, now what we're going to do is make sure. Let's add these up just to make sure, okay? We want them to add up to be 1 so that our probability, of getting 0, 1, 2, or 3 is all equal to 1. So here, that looks like my common denominator. It has to be at least as big as the biggest one. So it has to be at least 30. And 10, 2, and 6 all go into 30. So I multiply this times 3 over 3 to get to 30. I multiply this one by 15. And I multiply this one by 5. Let's add them up and just see, do we make it to 30 over 30? So that's 20 plus 10. Sure enough, hey, that equals 1. Yay! So we were worried about this, them looking funny. Maybe we're like, I'm not sure about it. But once I get to this point, I'm like, oh, thank goodness, it does add up to be 1. Okay, now I'm going to show you one more, and then I know we're over time. So the last one I'm going to do for you is that at least and at most 1. So let's look at these fish just a little bit longer to do the at least and the at most. So I want to catch at least 1 red fish. And we talked about yesterday that at least means 1 or 2 or 3. I have to have all of it. So I'm going to take, and I've already done 1 and 2 and 3. 1 or 2 or 3. So that or 1 or 2 or 3, what I could do, since I've already done it, is I could add them all together. I could take 1/2 plus 3/10 plus 1/30 and add those together. Or another thing I could do is I could use the complement. Notice that the 1, 2, and 3 plus the 0 make up the whole set. And at least 1 is this 1, 2, and 3, and this is like the other part of the set, the guy that's left out. So I could just find the probability of getting 0 and subtract that. So I'm going to use that complement. That's going to be really handy later when we're trying to find at least 1, the probability of something, or at most. Using the complement is going to be super helpful. And the way we do it is we just find then the probability of 0 fish, which is 1/6. We already did that. The probability was 1/6. And we say, okay, the complement then, so the complement of that 0 is equal to the probability of 1 plus the probability of 2 plus the probability of 3. These things are the same thing. The complement of this is equal to those guys. So, and it's also equal to 1 minus the 1/6. So this is equal to 1 minus the 1/6. Make it 6 over 6, and you got 5/6 is the probability. So for those of you who added up the 1, which was 1/2, or let's do it with the 30ths, 15/30ths, or 9/30ths, or 1/30th. Notice that when we do that, we get 10/25/30ths, which sure enough is equal to that 5/6. So one way to do it is to do the 1 or the 2 or the 3. But another way to do it is just to look at the complement of it. So using that complement sometimes is super, super helpful. Then at most 1, red. So that for at most 1 we said was 0 or 1. In that case, using the complement isn't going to help us any. Because here is at most 1. It's just that 0 and that 1. So the complement of it, though, is 2 and 3. It's just as much work to do 2 and 3 as it is to do 1 and at most 1. So I know that Mr. Simpson, I think Mr. Simpson uses a bar over it. Is that true, Mr. Simpson? You use this bar over it? And I know some people use the complement like this. So they're similar, but it's a little bit different, the symbols of it, the not. It's just that complement of it. Yeah, we could do it. You could either add this one plus this one to get at most 1, or you could add this one plus this one and subtract it. So they're both the same. To find the probability of 0 plus the probability of 1, this is at most 1. Or we could do 1 minus the probability of 2 plus the probability of 3. And they should end up to be the same thing. Either way, they end up to be the same thing. Yeah, or the word not 0, the probability of not 0. So there's lots of different ways to say that complement. All those different complements in there. Yeah, sometimes that's helpful. If you can see the complement, it does make it a lot easier, Bo. It makes it a lot easier. All right, now your job is to go do the classical probability homework. And then if you are having questions, I'm going to be on Discord today. I'm sure Rimpson and Jimson and the Leech will all be on Discord throughout the day too. If you have any questions, just put it up in our discussion, our stats discussion board, and we can work through those problems together. So hopefully y'all are having some fun with Tiny Tim and the ships that are killing each other. Sinking each other. Some battleship. Maybe you're playing Battleship at home because you're running out of things to do. Whatever. All right. So y'all have a great afternoon, and I'll see you tomorrow at 9 o'clock. The ships are a little confusing, so get on Discord and I'll help walk you through it. Y'all have a great afternoon. And tomorrow what I'm going to do is I'm going to do a task, one of the tasks, task 1 or task 2. I'm going to pick one of those and do it myself so that you can kind of see what I'm expecting from the tasks, from that the application exercise. That's what I mean, those application exercises. I'm going to do one of those. All right, y'all have a great afternoon. Math made simple at Simple Math at Simpson Math. You have a great afternoon.